Alright, so the last video, I was doing this problem and I realized I had typed all the stuff in wrong. So that was super fun. Alright, so I went in to list 1. You go to stat, edit, push enter, and then type in this in list 1, this in list 2. Alright, and when our window, so that we can see it, this guy goes from 0 to 15, so maybe 0 to, I don't know, 25, 20, something like that. And these guys, your grade is always a 0 to 100. So let's change our window. So push the window button and then go 0 to 25, 0 to 100. It should look like this. And then when we push graph, we can see it goes down, which is much better than what we were looking at earlier. So it kind of looks like that. I don't know if you can see these stuff. I'm done. Okay, hang on. Let's do that. Or actually, let's color a highlighter and you can see it better. All right, kind of like that. All right, and so that's not a positive correlation. That makes no sense. The more absences you have, your grade. So it's probably a negative. And then we need to compute the linear coefficient correlation. Correlation coefficient. All right, push that because we're in statistics. Go to calculate because we want to calculate it. And then go down to number 4. Push enter. Make sure that it says L1 and L2. And then push enter. Alright, here we go, much better. And so you see that R value. That R value says R equals negative 0.944. Alright, so we have a negative. Obviously makes sense because that's negative. And it's negative 0.9, which is close to 1. If we got a negative 0.6 or a negative 0.4, then that doesn't really tell us that much. It has to be close to 1 or negative 1. Otherwise, there's probably not a relationship. All right. So we have determined the R value. Once we determine the R value, we need to see how significant that relationship is. And so to determine how significant that relationship is, we're going to do some hypothesis testing. All right. So we're bringing everything together that we've learned. And some assumptions. The data is quantitative. Right? Remember that's when we use the t-test. Oh, what happens? I hate when it does that, guy. First world problems, I know. We use the t-test for quantitative data and we use the z-test for quantitative data. The proportion was not quantitative data, it was qualitative data. Right? Remember, quantitative data means numbers, qualitative data means categories. All right, and we're really going to focus on the t-test because we're not going to have huge samples. We're going to have small samples, and so the t-test is for small samples. All right, so it's approximately linear, it's quantitative, it's normally distributed, and there's not no outliers. All right, when we do hypothesis testing, this is going to be our null and our alternative. That should be a 1. And so it's kind of confusing. So just kind of focus for a minute. P equals 0 remember 0 was when the R value is 0, it's just kind of everywhere. Okay. When the R value is 1 or negative 1, if it's negative 1, it goes down. If it's positive 1, it goes up. Okay. And so this says P equals 0. It says there's no correlation because the R value is 0. This one says it is not no correlation, which means there is a correlation because it's a double negative. All right. Because we are, I can't stress this piece enough. So when we did the t-test before, we did n-1, and that was because we had one set of data. We have 2 sets of data. We have an x list, 2 variables, an x and a y, and because of that, we're going to use n-2. And I'll remind you of that piece. But we use n-2 for degrees of freedom. All right, sometimes what can happen when we're doing some hypothesis testing, we can have a direct cause-effect relationship, like it goes up or it goes down. We can inverse, so this is positive, this is negative. There could be a third variable. There's a whole bunch of variables that contribute to it, or it's just like a happy accident, okay? So for this class, it's just intro to stats. We're just going to focus on those two, or there's none, okay? Just know that this isn't the only thing that can happen between the variables. All right, so there's 3 ways to test for significance. We can do the t-test, and that we would use the calculator. I'll show you that at the very, very end. Or you can use table I. And so table I gives you the p-value, just so you know. And the steps that we would do is we would state the hypothesis and claim, which are always p equals 0, p doesn't equal 0. We would test it using our t-tester calculator. We'd find a p-value using table I. And we'd make a decision, yes or no, and then we'd summarize our information. All right, so when we use table I, notice it reminds you to do n-2. And so if we had 10 things in our data, we would use 8, and then it would tell us which alpha level, 95% correct, 5% wrong, or 99% correct, 1% wrong, and use that information. It's a lot of things I'm telling you, but like, let's put it together and it's not as scary. All right, so we're going to use table I. Test the significance of alpha is 1, so this guy, for n equals 41. So actually this should say, sorry guys, this should say 42. 42, okay, let's do n equals 42. That means the degrees of freedom are 40, okay, and we're going to compare it to this r. Oh, something, let me remind you. Let's go back just for a minute because I want to remind you of something. All right, remember how before we did p less than alpha, p greater than alpha, and if it was less than, we reject that we reject the null, right? And then we accept the alpha if it's greater. All right, we're going to use that same logic, but we're going to compare p and the absolute value of r. Okay, and r is what we get in our calculator. And so p is less than the absolute value of r. We're going to accept the null. We're going to accept the fact that there's no correlation. If p is greater than r, we're going to reject the fact that there's no correlation and say there is correlation. All right, so this is what we need to keep in mind when we make a decision. It's the same less than rules. Whoa. This I wrote backwards, guys. Oh my god, I'm a terrible teacher. Less than, you reject. Why I wrote it backwards, and I don't know if I said it right. Now I'm confused. Alright, it's the exact same rules, greater than, except. Alright. Same rules as this guy, and that's how we make a decision. I don't know what happened there. I'm silly. Okay, now let's do this problem. So if there's 42 things in our set, then we would go to 40, and our p-value is 0.393. And so we're going to compare our p-value and our absolute value of r. Okay, our p-value is 0.393, and our r was 0.307. That guy's greater. And so the rule was when it's greater, we accept. All right, so we're going to accept. Remember, the null is p equals 0, and the alternative is p does not equal 0. And so we would accept the null. We accept the hoe. All right, and so this says that there's no correlation. All right, what if I said, let's do alpha is 0.05. Okay, because this guy was alpha is 0.01. Let's do 0.05 and see if that changes anything. So 0.05, P is 0.304, and then the R was 0.307. That's less than, and so we would reject the HO. We would reject the fact that there's no correlation, which means you accept the fact that there is a correlation, positive or negative. Okay, and so let's review like what this means. This means that I am 99% sure that there is no correlation. This guy means I am 95% sure, or rejecting the fact that there's none. I'm 95% sure that there is a correlation. All right, and so that, it kind of makes sense. Do you want to say that you're like nearly 100% sure about something? And so it can change your conclusion. All right, so let's look at this guy, the one that we did. We're going to use alpha as 0.01. And there are 1, 2, 3, 4, 5, 6, 7. Right? Yeah, 7. That means that the degrees of freedom is 5 here. Okay, and when we did it, we got, calculate linear regression. Our R value was negative 0.944. Okay, and we want alpha 0.01. All right, so we're going to compare P and the absolute value of R. So the absolute value of negative 0.944 is just 0.944. And we're using this guy, 0.875, and he is less than. So when it's less than, you reject the HO. Remember, this is equals 0, this is not a 0. So we're going to reject the fact that there's no correlation. That's what that means right there. We're going to accept there's correlation. And in fact, it's a negative correlation. And so, just so you know, if we would have done 0.05, it would have been the exact same answer on this case because R is so high. So it is significant at 0.01, which means we're 99% sure that it has a negative relationship, which makes sense, right? So every now and then you've got a kid who misses a whole bunch but knows the material. But for the most part, the more that you miss in the class, the less higher grade you're going to get. All right, I'm going to pause this video, and in the next video, we'll go into the regression.